Well, now let's say we want to convert decimal to binary. This actually is very simple, a very simple method for doing this. We just keep dividing by 2, and the remainder is either, since we're dividing by 2, is either a 0 or a 1. And we're going to generate the binary representation of the decimal number from least significant bit to most significant bit as we divide. So after dividing the first time, the rightmost bit is going to be whatever that remainder is. Then we take the result of the division and divide that again, and again the remainder, and again the remainder. So let's try doing that and convert 23 base 10 to base 2. So we have 23 divided by 2 is 11 with a remainder of 1. So that's our first bit, our first rightmost bit. Then I'll take the 11, divide it by 2, and get a remainder of 1 again. So we have the next bit. Take the 5, divide it by 2, remainder of 1, 2 divided by 2, remainder of 0, 2 into 1 is a remainder of 1, and we're done. So what that says is that our number reading left to right here is 10111. So that's a 1 plus a 2 is a 3, plus a 4 is a 7, plus an 8, no 8s, plus a 16. 7 and 16 is 23. So it works. Well, now what if we want to deal with fractions? The way we deal with fractions is, let's say I have some number 0.1011 and I want to convert that to decimal. I now have to read this as, instead of 1 divided by 10, this is 1 divided by 2. Instead of this is 0 divided by 100, this is 0 divided by 4, etc. So this number is going to be 1 times 2 to the minus 1, which is 1/2, plus 0, 1/4, plus 1, 1/8, plus 1, 1/16, which is going to be 6.6875. So we keep representing just the way we do with the decimal number system, except we're doing it in powers of 2 to the minus x, 2 to the minus I, instead of 10 to the minus I. We can also do this and convert from a binary fraction back to a decimal fraction by continually multiplying by 2 and taking the integer part. And so the first integer part is going to be the first bit, and the second integer part will be the second bit, etc. Makes more sense if we see an example. So I want to convert that 0.8125 to base 2. So I multiply it by 2 and I get 1.625. So 1 is my first bit. I now multiply the 0.625 by 2 and I get 1 as my second bit. I now multiply the 0.25, so I'm multiplying this by 2 to get 0.5, and this is a 0 over here. And now I multiply the 0.5 by 2 to get a 1, so it's 1, 0, 1, 1. So, and that's reading from left to right here, 0.1101, to convert from a decimal number, fractional decimal number, to a binary fractional number. So, time for a joke, I guess. Only 10 types of people in the world. Those that understand binary and those that do not. So here are some questions that you can work on your own. Convert the following base 2 numbers to base 10. 10010 and 0.1001. So one's a a positive number and one's a fractional number, and convert the following base 10 numbers to base 2. So we now have to talk about how we represent signed numbers. So far we've been talking about numbers that only had absolute values or positive numbers. And there are really three different methods for doing this. The sign magnitude method, the ones complement method, and the twos complement method. And we'll be talking about them. In the sign magnitude method, the left bit is the sign bit. And in all these methods, if the left bit is 1, if the most significant bit is 1, the number is negative. In the sign magnitude method, if the remaining bits are just the magnitude. So if I have a positive 12 and I want to make it negative, I just turn the sign bit on and make it a 1. Several problems here. These sign bits don't work very well in computer logic to add and subtract things. And secondly, we have two different representations for the number 0. We have a positive 0 and a negative 0. That's going to give us some problems later on. There's another method called the ones complement method. And in this method, the positive numbers are the same as the signed magnitude. But negative numbers, we invert all the bits of what was the positive number. And since we inverted them all, the leftmost bit still indicates the sign. So if I start with our plus 12 again, and I invert or complement all the bits, 0 goes to a 1, 0 goes to a 1, 1 goes to a 0, 1 goes to a 0, 0, 1, 1, 1, and this guy indicates that it's negative. Some problems here. I still have two different representations for 0. Ouch. A negative 0 and a positive 0. So what the industry has pretty much decided on is to use what is called a twos complement representation. And in the twos complement, positive numbers are the same as the sign magnitude. Negative numbers, we invert all the bits of A, just as in the ones complement, but now we add a 1. So we invert and then we add a 1. In this case, the leftmost bit still indicates the sign, but look what happens. So we start with our 12 again. We complement each bit with our ones complement, and then we add a 1. Well, a 1 plus a 1 is a 0, carry a 1. A 1 and a 1 is a 0, carry a 1. There's the 1, 0, and the rest of these stay the same. So that's the twos complement. If you want, you can play around and take the twos complement of 12 and complement it again, so because the negative of a negative 12 should be positive 12, and I think you'll get back to where you started. This has a lot of advantages, or some advantages. First of all, it's much easier to implement addition and subtraction in computer logic with this kind of scheme. And there's only one number that represents 0, and guess what? It's all zeros, which is sort of makes sense. So a twos complement question is, what is the 8-bit twos complement representation of the decimal number minus 45? Well, we're almost done here with this session. What you should do, one of the first things you should do is install Sigwins on Windows if you're a Windows user. And there's a tutorial, a PDF file on the class site to show you how to do that. And you should pick the options to pick the default configuration plus the nano text editor plus Python. What Sigwin is going to give you is basically a complete or almost complete Unix, Linux environment on your Windows machine. And there are many commands and tools that we're going to be using in the next several sessions that you will want to have available on your Windows machine. If you have a Mac, these tools are already there. You can just run the terminal program. You can use Spotlight to find terminal. It'll open up a command window for you, and you can type things into it. So if you have any questions, please post them on the discussion board or email us. We'll be glad to talk to you, and we hope to see you on May 22nd. Bye.